So hello Year 10 and welcome back. For our first lesson this week, hopefully you remember, we looked at the two courses you did in Year 9, C1 and C9, and hopefully that either gave you confidence that you remember some of that material, or it pointed you in the direction of topics that you need to revise and review. In either way, hopefully it was useful. Today we're going to look at topics that we've done this year, this term or last term, so they should be more familiar to you, and that is C7, Organic Chemistry, and C2, Structure and Bonding, which we finished not that long ago. So again, we'll see how you cope with these longer answer questions. So we'll start with Organic Chemistry because that's what we did first. And organic chemistry, if you remember, was about hydrocarbons, alkanes, alkenes, various different functional groups, alcohols, carboxylic acids, esters, fractional distillation and cracking, why they're different and how they're different, what they're used for, and polymers, both the addition polymers and the condensation polymers, but ultimately most of those coming from crude oil, which was the overriding theme of this topic. So let's start with polymerisation. The equation for the reaction to produce a polyester can be represented by this. Now if you remember, this is called a block diagram. And the blocks in the middle, they just represent something that we can't be bothered to draw out in full, something that would just confuse it. You can replace that with CH2 if you want. Compare the polymerisation reactions used to produce polythene with the polymerisation reaction used to produce polyester. So compare, so we need to describe if we can find any similarities. But if not, we need to be careful to describe the differences. So the one used to make polyethene, and hopefully you remember that that is an addition polymer, with a polyester, which as we see above is a condensation polymer. So you should know this, so I'm not going to give you time to go back and look in your notes. 4 minutes, pause the video, come back for the mark scheme. So any four of these things. Well, the first thing, and I kind of gave this away, polythene is produced by addition polymerisation, polyester is formed by condensation polymerisation. And actually nowhere in the question did it say that, but hopefully you would have got that mark there. This is one of the ones that I highlighted to you. Polythene is produced from one monomer, whereas polyester is produced from two different monomers, and that was one of those key points that I highlighted to you. Polythene is the only product formed, whereas polyester, water is also formed. That was the second thing I highlighted to you. So hopefully you would have got that. So what do you get the fourth mark for? Well, you could say that polythene is being produced from alkenes, whereas polyester is being formed from carboxylic acids and an alcohol. Okay, maybe that was too obvious to you guys, but if you're scrabbling around for 4 different marks, then that's what you would hopefully have stated, and it was fairly obvious. Perhaps you thought it was too obvious to put down, but you should have been able to get 2 or 3 from that. Making ethanol. One of the very first homeworks I gave you this year was where you had to compare and contrast the 2 different methods of making ethanol. And here it is, the question in all its glory. As explained, ethanol can be made using either sugar or alkanes as the starting material. Evaluate the advantages and the disadvantages of these using 2 starting materials. So there's 4 points available. So we probably want an advantage of alkenes, and we want a disadvantage of alkenes. We probably want an advantage of sugar, and we probably want a disadvantage of sugar. And if you can come up with those 4 points, you're almost certainly going to get the 4 marks available. So here you go. Pause the video, come back for the mark scheme after 4 minutes. Right, any 4 of these. Advantages of using sugar. So, sugar is a renewable resource. You hopefully got that. Or crude oil is not a renewable resource. That doesn't count as 2 separate points. That would only get you 1 point. So sugar is renewable, crude oil is not. Sugar is carbon neutral. So in order to grow the sugar, it takes in CO2. So that is an advantage of sugar. You don't need as much technology. So that would be another thing that you could have said. What are the advantages of alkanes? Well, hopefully if you're remembering your first homework, you know that the alkanes produce a very pure product, about 100% pure. It's much faster. It is a continuous process. And so between those points, you really should have got 4 marks that were valid and would have counted towards your total. There are other things here. You could talk about a third world country not being able to afford big oil refineries, the fact that if you've got a really nice sunny climate, then growing sugarcane is nice and easy, or if you've got loads of land, that's not a problem. But I think the ones I've ticked are the most obvious ones for you to put down, and you only needed 4 of those. Notice it says at the top, candidates must include both sugarcane and crude oil in their evaluation, and both an advantage and a disadvantage of each to get full marks. So just as I said, if not, the maximum mark is 3. So you did need an advantage and a disadvantage of each to get full 4 marks. I'm sure those of you who are on the ball knew this question was coming up. It does come up pretty much every other year in the exam. So, can you explain fractional distillation? Most of the compounds in crude oil are hydrocarbons. Hydrocarbons with the smallest molecules are very volatile. Describe and explain. So, describe and explain. So make sure you're saying how the petrol is separated from the mixture, and do make sure you're talking about the petrol coming out here. This is a 6 marker. So you've got 6 minutes. Pause the video, come back after that time to see how you got on. Right, now I would really hope for this, all of you would be going for 5 or 6 marks out of this level 3. A reasonable explanation of how petrol is, all fractions are separated from crude oil, mentioning evaporation and condensation. Notice, and I've highlighted this many times, if cracking or a catalyst is described as part of the process, in other words, if you don't know the difference between fractional distillation versus cracking, then the maximum is level 2, 4 marks out of 6. So if you talked about breaking bonds, or you talked about using a catalyst, any of those things that are associated with cracking, you are limited. You must make sure you know the difference between fractional distillation and cracking. So any of these points would count towards your total. It's not as simple as saying that you need 6 of these points to get 6 marks. But did you talk about evaporating most of the crude oil to form vapours? Did you talk about the fact that the process is even called fractional distillation, because that wasn't given in the question? Did you talk about heating the crude oil in order to make it evaporate? Did you talk about gases rising up the fractionating column and cooling as they rise up through the fractionating column? Did you talk about the fact that when they've cooled beyond their boiling point, lower than their boiling point, they will condense? Did you talk about the fact that hydrocarbons with low boiling points come out near the top, while hydrocarbons with high boiling points come out near the bottom? Did you talk about the fact that some hydrocarbons, for example bitumen, remain liquid and flows out the bottom of the fractionating column? Did you talk about the fact that some of the hydrocarbons stay as gases even at room temperature and come out at the top of the fractionating column as LPG? Did you specifically say there's a temperature gradient in the column which is cool at the top, hot at the bottom? You really should have been able to get 5 or 6 marks out of that because you have seen this question so many times. This one, however, is a little bit more new to you. Most car engines use petrol as a fuel. Petrol is produced from the fractional distillation of crude oil. Crude oil is a mixture of hydrocarbons. Sulfur is an impurity in crude oil. Car engines could be developed to burn hydrogen as a fuel. Hydrogen is produced from natural gas. Natural gas is mainly methane. So table 2 shows some information about petrol and hydrogen. State at fuel temperature, petrol is a liquid while hydrogen is a gas at room temperature. In combustion, petrol and oxygen produces carbon dioxide and water, while hydrogen produces just water. From 1 gram of fuel, petrol produces 47 kilojoules of energy, hydrogen produces 142 kilojoules. Describe the advantages and disadvantages of using hydrogen instead of petrol in car engines. Use the information given and your own knowledge. So you need to bring something else to the table that isn't just shown in the question. So you've got to interpret the table, but you've also got to use your own knowledge to answer this. This is a 6-mark question. So 6 minutes, pause the video, come back to see how you've done. Right, why is hydrogen good? You should have mentioned from the table combustion only produces water, so there's no pollution. You could have discussed, again from the table, that hydrogen releases more energy, so less fuel is needed, or hydrogen is more efficient. And those 2 things came from the table. A disadvantage of using hydrogen from the table is that hydrogen is a gas, so it is difficult to store or transfer into the vehicle. So those were 3 things that came from the table. Could you come up with 3 other things? Well, you might have discussed that although hydrogen is currently coming from natural gas, there are renewable ways of producing hydrogen. For example, electrolysis of water using solar power. You could talk about burning petrol from C7. You know that burning petrol produces carbon monoxide and particulate matter, and that this is harmful. You hopefully know that hydrogen gas is extremely flammable and can cause explosions. And going completely into your own knowledge here, you could talk about the fact that hydrogen won't run in existing car engines, so everybody would either need to buy a new car or all engines would have to be modified. And you could talk about the fact that very, very few filling stations actually have hydrogen, so it would be difficult to refuel your vehicle. Now I suspect you may have got 3 or 4 points there, but it would be interesting to see how your ideas compared to the answers here on this question. Moving on to the very recent C2 structure and bonding. Now here you really should have all this information at your fingertips, so you shouldn't need to go back and look any of it up. First question. This question is about sodium chloride and iodine. Describe the structure and the bonding. Okay, so make sure that you're talking about not just the type of bonding in sodium chloride, but also the structure of sodium chloride as well. 4 marks, 4 minutes, off you go. Right, well, sodium chloride is obviously ionic, so it is a giant lattice for 1 mark. It is ionic, so 1 mark for talking about that. You have to describe how it contains sodium plus and chloride minus ions. Accept in words or dot and cross diagram must include type and magnitude of charge for each ion. Okay, so it has to say that it's 1 plus and 1 minus, not just in nondescript positives and negatives, okay, for 1 mark. And you have to say that these things are held together by electrostatic attraction. So this was actually quite hard to get all 4 marks really, because you had to really predict what the examiner was going to ask for. But I would suggest that the diagram, if you did that, you just drew a diagram of sodium chloride, you probably would have got at least 2 out of those 4 marks for showing the ions and Na plus and Cl minus. Now on to the iodine. Hopefully you knew this question was coming as well. Explain why iodine has a low melting point for 3 marks, and explain why liquid iodine does not conduct electricity for 2 marks. 5 minutes, pause the video, come back for the answers. Right, if you didn't get 3 out of 3 for this top molecule, then bang your head on the desk, because this, along with fractional distillation, is one of those that comes up pretty much every year. Okay, you have to talk about the fact that iodine is simple molecular. It's pairs, diatomic, simple molecules, small molecules, anything like that. And between the iodine molecules, there are weak intermolecular forces, weak forces between molecules. And these take little energy to overcome, or these forces are weak. Any reference to weak covalent bonds negates the second and third marking points. So if you have talked about weak covalent bonds, you get 1 out of 3, and I will smack you on the back of the head, because how many times do I need to tell you about this, alright? As for why liquid iodine doesn't conduct electricity, well, it has no free electrons, it has no free ions, so cannot carry charge. You might have said iodine molecules are uncharged. That would get you 1 mark out of 2, but there's no free electrons, no free ions, no free charge carriers, nothing can carry charge. Hopefully you did all right on that and got 4 out of 5 or 5 out of 5. Looking at the other types of bonding, drill heads are made from steel. Steel is an alloy. Explain why alloys are harder than pure metals. So explain. So why are alloys harder than pure metals? 3 marks, 3 minutes. Drill heads also contain diamonds. Describe as fully as you can the structure and the bonding. Seen that before already in diamond. 4 marks. So 7 marks available here. Pause the video for up to 7 minutes. Come back for the answer. Right, so why are alloys harder than pure metals? So you've got the idea here of an alloy being a slightly larger atom that disrupts the structure of the metal and doesn't let the layers slide. So one mark for talking about the atoms or the ions or the particles in an alloy being different sizes, one mark for that. Don't allow reference to molecules and ignore reference to compounds, because of course alloys are mixtures. They are actually, as we've seen from C8, formulations, but they are certainly not compounds. So the layers are distorted, that's the second mark, and the layers can't slide or slide less easily for the third mark. Accept all marking points in a suitably labelled or annotated diagram. So you can't just draw this, but you've got to sort of show that the layers can't slide. If no other marks than simply for knowing that an alloy is a mixture of metals, you can have one mark for that. Describe the structure and bonding in diamond. Well, whether or not you remembered that diamond is made of carbon tetrahedra. I don't know, but the idea that it is a giant structure or a giant lattice for one mark. There are very strong covalent bonds between all the carbons for the next 2 marks, and some description of each carbon forming 4 bonds or a tetrahedral structure for the final mark. And we've seen that before. That was in your end of topic test. So you should have done well there if you paid any attention when we went through that mark scheme. Last question, a bit more of a sort of data interpretation question. Magnesium oxide nanoparticles can kill bacteria. The figure below shows the percentage of bacteria killed by different sized nanoparticles. So we've got the size of the nanoparticle in nanometers against the percentage of bacteria killed. Give 2 conclusions that can be made from the figure above. So 2 separate conclusions, explain them fully. 2 minutes, and that'll finish today's lesson. Pause the video, come back when you've come up with 2 conclusions. Right, so you had to talk about the conclusions from within the data. So that was type 1 and type 2 bacteria looked like that, and that was percentage killed against size. So the most obvious thing to me is as size increases, the killing goes down. So as the size increases, nanoparticles are less effective at killing the bacteria. Okay, I think that is the most obvious conclusion you can make. The second most obvious thing to me is that type 1 bacteria are always more killed than type 2 bacteria at any size. So type 1 bacteria are more susceptible than type 2, or type 2 bacteria are harder to kill by the nanoparticles. The other things you could have talked about is that one of them shows a more linear relationship than the other one, or you can talk about the fact that 100% of bacteria are killed with the small particle size here. Okay, so you could be specific about that. Well, again, hopefully that was useful. to help you remember what you do and don't know about C2 and C7. Again, if you've done this properly, you've paused the video and had a think about these questions, that should have taken you an hour. Do ask me if this has thrown up any questions. Have a nice week.